Now let's try an example for a stoichiometry. Now the first thing we have to do is read the problem and identify the key components of the problem. So it says when excess barium nitrate was added to a beaker containing a solution of aluminium sulfate, 5.835 grams of barium sulfate was formed. Given the equation is aluminium sulfate plus 3 barium nitrate gives 2 aluminium nitrates and 3 barium sulfates. Determine the mass of the aluminium sulfate present. Now, because we've been given a quantity here, this tells us this is our known. So I'm going to write this above the equation. Because we've been asked to find the mass of the aluminium sulfate, this is our unknown. So we've identified our known, our unknown, and it's now time to do our stoichiometry. So the first step in any stoichiometry is pretty much find a mole. So in this case, we're going to find the number of moles of barium sulfate. So we go the number of moles of barium sulfate is equal to a mass over the formula mass. So in this case, the mass was 5.835 grams, and the formula mass we get off the periodic table. So we go to our periodic table and add it up, and it comes out to 233.37 grams. Now from there we do our little calculation, and it comes to 0.02500 moles. Now at this point in time, I actually store this information in my calculator ready for use later. Please note that I have told my marker that I'm actually finding the moles of barium sulfate, and I've shown the formula that I'm using. This makes it very clear to anyone who's marking my calculation what I am doing. Now the next thing that we need to do is find the stoichiometric ratio, and to do that we have to use our balanced chemical equation. So in this case, to find the number of moles of aluminium sulfate, it is equal to an unknown over the known times the moles of the known. In this case, the moles of the known are barium sulfate. Okay, the unknown. The unknown's coefficient is 1. The known's coefficient is 3. The moles of barium sulfate is 0.02500. So in this case, our stoichiometric ratio is 8.33 by 10 to the negative 3 moles. Now once again, I'm still storing this information for later use. Now we're at our final step. We have to find our mass of our aluminium sulfate. Now I rearrange my equation, so it is equal to number of moles times formula mass, the number of moles we've previously calculated, the formula mass of aluminium sulfate. I go to my periodic table and work that out, and it comes out to 342.17. So in this case, it is 2.852 grams. Now please note that I've provided an answer to 4 significant figures because our original problem had a mass to 4 significant figures, and it's always very important that our final answer is in the correct number of significant figures.